Hello and welcome to Build Week 1 for CSPT12 and CSPT13. Today we're doing a joint kickoff with the two cohorts. This is just going to be going over the basics of the idea of the projects that you've got available and the workflow of what you're going to be doing over the course of this time. So I'll just jump in and share my screen. And we can talk about the initial web project, and then we'll go on and see about any DS ones as well. Let's move this and give a bit of real estate to the screen. Right, so the general initial generic one that we've got available for this build week is a project to do with cellular automata. It's a Conway's Game of Life. It's fully Turing complete, and it does have all the aspects that you would want to actually show if you've managed to grasp all of Unit 1's material. It's a fairly well-known algorithmic challenge. It's a fairly well-known sort of project set, and we've used it a lot in Lambda School. Originally, I believe it's been used in several build weeks prior to our current build week structure. We've also done it in Python. We've done it in a load of different languages and a lot of different forms along the way. This is the culmination of all of those put together into an actual build week project. The Game of Life itself is suited well towards actual automata. It's also suited well towards creating a project that is going to encompass many different aspects of computer science. It's basically a set of rules that is set out in a certain way. And if we take a look here, you've got the Game of Life. It's from basically the 1970s, so it's been around for a while. It literally it literally simulates a bunch of cellular automation where we have these cells in a grid that behave in a certain way based upon a certain set of rules. And there's not that many rules to the actual overall thing. If we take a look at the general idea of it, where are we? What you've actually got to do for it is build up this whole structure. Now, you can do this in your core language, whether that's web, iOS, Android, whichever language it is, and whatever actual setup that you want to use. But the overall end result has to follow a certain set of things. And a couple of things we need to speak about is collaboration. One of the things what we've had in the past is people collaborating on the planning, but then they end up collaborating and trying to pair code or mob code the overall thing. And I'm afraid that's not actually the way it's set out to do. The coding of it and the overall actual coding stage or the actual programming stage, once you've got a plan in place, is actually a solo thing. So it's not a team project. It's not a project to be taken on by multiple people. It's not like, say, labs or any other project where you would have done that. Treat it almost in a way like a sprint challenge. So in essence, it's a little bit different to that because we can allow you to look at the planning and understanding phase as a team. So you're perfectly welcome to jump in and work together to plan, work together to understand what the problem is. But then when you're actually creating the thing, that's when it becomes a solo project. So you're welcome to not collaborate if you really, really want to work on the whole thing from start to end alone. That's up to you. But you just know that you're allowed to actually cooperate in the understanding and the actual planning phase. And then once you've actually finished doing it, you're also welcome to kind of talk about reflections on how you maybe would have done it differently with each other. So it's just purely these things about you can't really ask for help during the coding phase among your peers. That's the only major league difference there, okay? So again, you can clone the repo of this actual project, but usually we recommend you starting from scratch because it depends entirely what language, what framework, and what construct you want to use to make this. We've had people use Pygame in the past. We've had people use React in the past. We've had people use all sorts of different things, even languages that we don't even teach here. They've just went out on a limb and just created these amazing projects. As long as you can cover these objectives, technically it doesn't matter what language, what construct you make it in. We do advise to work in a language and a framework that you do know, so that you're not sort of having to learn a new language or learn a new construct in the middle of trying to do a build week. We're not discouraging you from learning new things, but we would say make sure that you're comfortable, at least in the language, what you're going to try to do this in. But the objectives, let's quickly go over these. Basically, you should be able to create a unique, high quality project that can be added to a professional portfolio. So if you made this, for instance, I don't know, in assembly, and you had it text-based, and you had it in a way where it wouldn't load into a web portfolio and wouldn't really be useful to sort of show off your skills in your current track, then that wouldn't really be meeting this objective. So think about that when you're actually making this and polishing it and making it into some sort of a project. Also, students should be able to describe the rules of Conway's Game of Life. So you're going to have to research and look up what those rules are. There's not many, so it's not that complex. It's just one of the things that you're expected to understand as you move forward. Students should be able to explain what cellular automata is and describe how they're used in real life and how useful it can be in real life. What sort of things, sort of, let's use an example of, say, COVID-19 modeling the outbreak of some sort of a virus or a pandemic as an example, just or anything else that you want to kind of research and understand about that. Students should also be able to correctly analyze the Turing completeness of Conway's Game of Life. So this itself lends itself to computer science in essence, because Turing completeness says that something can, if a problem is computable, then if something is Turing complete, then it should be able to compute any computable problem. So in essence, using the actual constructs of Conway's Game of Life, you should be able to make the equivalent to, say, NAND gates. And a NAND gate would be Turing complete. So it's up to you to research that and understand and analyze how that actually results in that. But it's another thing that's one of your objectives. Also, students should be able to implement a visualization of Conway's Game of Life using technologies related to their specific track. So this in itself kind of says, ideally, you want to be making at least part of this project in your track specific language, because that would be covering this objective. It doesn't mean that every little bit of it has to be done in that language. You can break this up into smaller pieces and make it like a front, back end, whole massive thing if you wanted to. But always be aware and mindful of feature creep. So try not to add extra features and get on with loads and loads of bits of it until you've got the MVP working. But I think that goes via no matter what the project is that you're working on, really. Also, students should be able to utilize double buffering to implement the game. So here's another objective. Now think about this. First off, you'd have to understand what double buffering is. You'd have to think of a way how to implement it using the technology that you already have. So whatever your core track language is or your core track's construct is, how would you implement some form of double buffering in that language? For instance, if it was maybe, if you use web, you might use Canvas and you might have like multiple buffers and then just do a flip on it or something like that. Similarly, if you're using Python, you might use Pygame or OpenGL or another SDL sort of based thing or something. So it's all down to research and understanding the problem. Now, let's go over what your minimum sort of features are. Initially, first, you need to be able to research Conway's game of life. Understand how it works. Why is it useful? So also, what's this whole Turing completeness and how is it related to Conway's game of life? So this is some preliminary research work you need to be doing. Then you've got to build an app. So the app, you want to sort of like visualize this game of life that you've researched. Think about the main entry point of your application. It's got to house the actual visualization of the cellular automation. It's going to include necessary components such as the grid, which will be displaying the cells. You want maybe a cell object or component, for instance, that should have properties like the current state, whether it's dead or alive or has a color, whether it's black, white, red, green, whatever those two contrasting colors are that you want to use. You want to make it clickable or tappable. So you want to be able to have the user click and set up the initial cell configuration by like clicking on all the cells. It shouldn't be clickable though while it's running, because that could mess up the whole idea of it really. Behaviors as well, you want to hold behaviors on there. So to be able to toggle the state or functionality and switch between dead or alive. So you want to be able to manually toggle the cells before starting the simulation, but you also want it to automatically, based on the rule sets, be able to change life and death of a cell. You also want to think about what an appropriate data structure to hold your grid of cells would be. Think about that. Whether you'd want like a list, whether you want a two-dimensional list, whether you want a dynamic array, whether you want a flat array, whether you, what sort of structure you want, whether you wanted like a weird linked list or some other thing. Just think about what sort of a data structure would make sense for a grid. Now, bearing in mind, you want at least 25 by 25, but you can go as big as you want. Now, think about this though. When you're scaling, think about your algorithms you're using to make the things happen. You want it to be scalable enough so you can go X, Y, Z amount, but you don't necessarily want to spend too long on thinking about just that. So I'd say make a 25 by 25, maybe a 50 by 50, and see how it scales. And then once you've got the base MVP working, you can always scale up and figure ways of optimizing. You also want to have the text to display the current generation number. So basically, each time things live and die, that'll be the next generation, next generation, next generation. So you want that kind of counting up as you go through each of these stages. Ideally, you want some sort of a timeout function to build up the next generation of cells and then update the actual display at the chosen interval, because you're going to probably want to make it slightly faster or slower depending on how you want it to be set. You're going to need buttons to start and stop the animation. So you need to think about what constructs you're going to use for this. Are you going to use like web-based stuff? Are you going to use anything else? It's entirely up to you. You want a button to clear the grid as well. Now, on the back end or the idea of things, you want to write algorithms to actually implement the things. So first off, you want to implement the following basic steps. So think about for each cell in the current generation's grid, first you want to be able to examine the state of all 8 of its neighbors, okay? You do have a couple of options when it comes to getting to the edge of the screen as to whether you want it to wrap around to the other side of the screen or not, or the top and bottom, whether you want to wrap the bottom down to the top again. So think about that as well. You need to apply the rules of life, okay? And you can look those up. So when the main loop completes, you want to swap the current and next grid. So it's almost like you've got this static idea. You've got this current frame, which has the current set of grid. Based on some rules, each of the grid items, the cells, are going to change, and they change to the next generation. Once you've drew out that next generation, you can just swap out those images, and then you have your new generation. And if you do it fast enough, it becomes animation. So you're going to carry on and you want it to keep doing that and keep doing that until the simulation literally stopped. So you also want to do the algorithm where it's breaking down the steps into smaller subtasks, maybe with helper functions. Think about these things. These are all showing good software engineering practice. You also want it to be very readable, because at the end of the day, source code is not for computers. Source code is for people. So it's not a lot of use if it's not readable. Ideally, you also want it to use double buffering to update the grid to the next generation to cover some of your objectives. Again, if double buffering is confusing to you, remember to look these things up. You also want it so that it can be well documented. As in, for instance, whether you want to decide whether when you reach the edge of the grid, do you want it to wrap around to the far side? Or do you want to just have it say, no, that's the end, you can't move further? So you need to document this and have information and kind of make sure that it's understandable as to what you're expecting it to do. There are also a few custom features. Now, this is up to you to choose at least 3 of these for MVP. So you still need to, do all of this here, as well as the preliminary work, and then implement at least 3 of these features. So create a few sample cell configurations that users can load and run. So maybe you'll click around and make some spinners, make some different things and save that as a configuration. And then when a user clicks a button to load that configuration, it loads that one and maybe a few other ones. Add an option that creates a random cell configuration. So just randomize what cells are alive and dead. So that's another option. Add additional cell properties like the color, the size, and incorporate them into your visualization. So in other words, have it so that you can either have resizable cells, for instance, or you could have different colored cells that maybe is user interactable. So the user might be able to choose color or something like that. Also, you might want to allow users to specify the speed of the simulation. So you might want like a slider or a toggle box or a multiplier that kind of they can choose the speed. Also, provide functionality to manually step through the simulation. So this kind of goes hand in hand with speed and stuff, because you could actually have it so you could say, okay, oh, just do it one step at a time and click a button to step to the next generation, and maybe have a history where you can step backwards and forwards through it to see what happens throughout the time. Allow users to change the dimensions of the grid being displayed. So that kind of goes hand in hand with the idea of making a 25 by 25 grid and then maybe another one and a few other sets of decisions on how big you want to go. Again, you're going to want to test and have a little play with your algorithm and make sure that it's scalable, because you don't want a user to be making this massive grid that just doesn't work at all. Given a specific generation, calculate the configuration of the cells at that point in time and jump to that state, bypassing animation. So as long as you have your algorithms well made, you should be able to do that with no problem. So look, if you have an idea for a custom feature that's not on the list, run it by your TL and see what they say. If it's not too much of a crazy feature, I'm sure that it's perfectly fine to go through it. Let's look. Also, you want to create like an about thing. So you want maybe an extra pop-up or a modal or something that explains and describes the 2 main rules of birth and death of Conway's Game of Life. So like a write-up, you might want to put like a little bit of information about Conway themselves and some other bits and pieces, but that's up to you how deep you want to go into this. Some people have actually made a whole blog and linked to it. Other people have just had a modal with some of the rule sets in there and things like that. Then we have some stretch goals. If you get all of your MVP done, you're also, for stretch, you can just implement another couple of things that are on this list. So once you've done like 3 things, if you want to, you can stretch yourself and implement more. You might want to deploy your application to some sort of hosting service or move into an app store if you're doing a iOS or a Android version. Think about where you're going to deploy it and how you'd want to have it seen by potential hiring partners. Also, another stretch goal, write a how-to guide or a blog that walks the readers through how you actually built this and how you planned it and your steps, basically like a dev log. Also, maybe expand your simulation into a 3rd dimension. So think about making a 3D Conway's game of life. Maybe using OpenGL, maybe using WebGL, maybe using something else entirely. Also, explore alternate algorithms for finding the nth generation. Okay. Take a look at hash life and sort of have a little feel about it and see if you can make it so you can generate a certain nth generation of Conway's game of life and optimize. Here's some sample wireframes. These are not absolutes. This is not saying this is how you have to have your stuff. This is just an example of how it could look. Here's an example of iOS. You might have a page with the information there, game of life, what generation number it is, and a display of the oscillators and spaceships and everything. Yeah. And this would be like your grid, for instance. So when you click on a certain preset, that would be whatever the preset is that's been set up. Also, if you click on the about or question or information button, it may go to an about page with all the rules and all the information about the algorithm. Then maybe on a desktop or tablet, it may look a bit differently. You might have sort of like your generation, your name, you've got a few different presets with maybe pictures of those presets as to how they would look. Then you could have like your grid of cells, which would maybe be resizable. Play, pause or stop button. And maybe there's more buttons depending upon how you've chose to do it. And your rule set. You could always have that as a modal, and maybe if you want to use more of your real estate for the actual grid. And then more information about the algorithm itself. There's a few practices that we'd like for code and repo quality. It's not a requirement, but ideally, make your code look sharp and professional, because if you're going to show it to someone, you don't want messy code. You don't want to go to a hiring partner or a hiring manager and go, hey, here's an example of my work, and they can't read it. So you want to make sure that you keep it professional looking. Think about how you would want to read something if it was someone else's. If you want to look at something and understand it, make sure it makes sense. Make sure you comment when it's needed. Maybe give it doc strings depending upon the language you're using. And just make sure it's very, very clear as to what it's doing, so that it almost reads itself. So people can just look at it and understand what it was that you wanted it to do. Make sure that your repo is well organized and your directory structure is clear. Make sure you've got a good README that helps the reader understand and navigate your code. And if there's a requirement for installation or a requirement where maybe if they wanted to deploy your code somewhere, maybe you want to put down in the README how you would deploy it and how it would be used locally. Also information about what the project is, what sort of problem does it solve, what possible difficulties there could be and what solutions there were. Also, if there's other things that you would like to add to it, this is a good thing to add to your README anyway at the start and make it maybe tick boxes so you can kind of tick off when you've done the bits that you want to add. So that's always useful. There's a rubric to check whether you pass or fail, basically. So your simulation retriever 2, when it's satisfied with the following. Display includes a text area that shows the current generation of cells being displayed. Also includes grid of cells, at least 25 by 25, that can be toggled to be dead or alive. Includes working buttons that start and stop the animation and clear the grid. An algorithm to generate new generations of cells correctly implemented. at least 3 features from the custom feature section successfully implemented. And the application includes a section outlining the rules of Conway's Game of Life. You may get a 3, and if you get a 3, it will need to satisfy all of the above requirements and implement one of the other stretch goals as well. Only one or more stretch goals will get you a 3. For track-specific help, if you're a DF student, use your cohorts channel. Look at where, talk to your peers. For iOS, if there are any iOS students here, use the iOS help channel. And for web, again, use your cohorts channel. You're welcome to cross-collaborate on ideas between DS, web, iOS, or any other track you like. But remember, that's only in the planning stage and reflection stage, not in the coding stage. So try not to jump into something you're not too familiar with, where you'll need help from a different track in actual coding time. There's other resources around for other platforms, which you're welcome to go off and look at yourself. Okay, that's the sort of web iOS track project. Now there's a separate data science build week repo for those in data science who choose to, they don't want to do the cellular automata. If you want to just do pure data science, then we have a repo for that. You're welcome, although, as a data scientist, to do the web-based stuff. It'll add to your portfolio, it'll add something different, but you may think, well, it's not going to do any good for me. It's not going to show my core strengths. If that's the case, there's a bit of a data science build week repo here, so I'll jump into that. So this repo is a little bit different. This is more going over and implementing different algorithms. So you're going to be looking at these algorithms that already exist, but your version of them needs to be done, okay? So for part 1, you want to be picking one of the algorithms that you want to work with. Now, the idea is your algorithm needs to be implemented in a Python class if you're going to do the actual data science. You should have the following methods: a fit method, predict method. Remember that you're only allowed to use base Python. Things like NumPy and SciPy are allowed. But remember, to implement your core algorithm of choice and visualization and stuff, you can use other libraries. Yeah. But remember that the actual algorithm itself, you want to be writing that yourself. You don't want to like just include an algorithm that's already ready made. Otherwise that kind of negates the point of what you're doing. Okay. You also may reference any outside materials that you need, but remember, copying and pasting another open source implementation is absolutely prohibited. So you can't just go, hey, there's a k-means clustering. Somebody's already made one of those. Let's copy and paste it. I'll change a few things and maybe rename some variables and I'm done. That's obviously not the best way of doing things if you want to learn how to do something or show that you know how to do something. That just proves that you know how to copy and paste. And although copying and pasting is a skill in itself, I suppose, it's not exactly what we're looking for, not for this. So basically you can use different data sets to actually visualize these things. You can find some in this library. You can run around and look in other places. We have had students, data science students, use different data sets. They've sometimes even used their own data sets for certain visualization and different things. But again, I'd say talk to your track specific help channels for the information on things like that. Now, for the second part of this, you need to write a how-to that describes the algorithm and how to implement it from scratch. So you need not only to be able to actually implement it, you need to be able to explain to someone else who has never implemented one of these algorithms before how to do so. Also explain to them what's it useful for. Okay, the actual target audience should be other developers who have never seen the algorithm before. So somebody who's never seen a decision tree learning algorithm or a K-means clustering algorithm, you want to be aiming it towards them. So explain, not necessarily a complete novice, but somebody who's never actually seen any of these algorithms before, explain how you would make it, how you would write that algorithm out, how you would approach it from start to finish. Also, what is it used for? So there's no size limit to this, but basically you want the reader to be able to begin to implement the algorithm based on the information that you presented. Yeah. You can either post on your own blog site or any other blog site that's around. You can pop it onto a platform like Medium or any of the other ones out there. Right, that being said, we don't encourage this as such, but anyone who does want to start jumping onto a data science track, problem set and build week, who isn't data science, are also technically welcome to do so. The only problem is it means that you're going to be putting yourself at a slight disadvantage in doing so, and it may be moving away from your core and the things that you want to work towards. So bear that in mind if you decide to do so. There's another portion to this. There's the unit assessment. Okay. That's another part that we'll be talking about, not in great detail, but there's an actual FAQ that I believe has been dropped in both channels, so we should be okay for that. Let's have a little look over it though. So why are we getting auto-graded test? We've got a few purposes for that. Firstly, it provides feedback loop. So we get an idea of what areas you need to improve in and basically what problems you have with anything that you've learned. And it also shows us an idea of where you are in the standing of everything. It prepares you for scenarios that you'll likely encounter during the job search process, because you're going to be hit by graded tests throughout your job search. So it kind of gives you a little bit of a funnel there. It also provides the instructional staff, such as myself, with data on individual students' knowledge. So we know kind of a little bit more as to how to approach teaching the student if we know where they're actually standing in their understanding. It'll also be used for data on frequently missed questions to inform areas how we can teach topics better. So it helps us to help you. So another question we get asked a lot is, what happens if I score lower or below the threshold on the assessment? The idea here is it's supposed to help you understand your mastery. It's not necessarily one of those standardized tests where it's like, oh no, all is lost and you're going to fail everything if you don't pass this 100%. It's there to kind of give us an idea. Ideally, for Unit 1, a score lower than 50% is going to inform us that maybe you should look into a more deeper dive of the information that you've already been given, and maybe try to relearn some of the subject matter and see where it is that you needed help with. Okay. So when will it happen? I believe these times may not be set in stone, so you may need to speak to your specific TL or SL about this. But where are we? Part-time unit assessment for all units, all tracks, first 90 minutes of your A week, 5th day. That's what it's set down to, but that may be changed. You need to speak with your SL and TLs about that. Also, unit assessment retake, if you need it, any point during the B week at your convenience, as long as it's completed by 11:59 p.m. Pacific on the Thursday of that week. Okay. Deadline to take the assessment, including the reattempt, is Thursday of the B week. Okay. Again, if there's any changes to this, speak to your TLs and SL in case there's anything, new updates or anything. But this is generic and generalization as to what we've been doing in the past. Another question what gets asked a lot of the time is, why is this happening during build week? Well, the idea here is it's a dedicated time so that we make sure that each student can individually achieve the mastery of these learning objectives. Okay. And it helps us to move forward in our teaching. Again, this is kind of a repeat of something else, but can I retake the unit assessment if I don't pass the first time? Again, you'll be able to take the assessment again if you don't pass the first time. You're allowed one reattempt for a total of 2 tries if needed. So you can retake the assessment as long as it's within the time limit with no problem. And you'll be able to get a link off your TL for a retake. Right, let's have a look. Who grades the unit assessment? It's literally auto-graded. So you'll get emailed a total score at the end. So we don't really have, we don't specifically grade ourselves or anything like that. It's all completely automated. If you do have any problems with emails and stuff, do let us know as soon as possible so that we can kind of get that sorted. Let's look. What does the unit assessment include? How do I know the objectives, what to study? It's literally going to be covering what you've been learning. So hopefully just study the things what you've already gone through in Unit 1. Okay. So looking, I'm not trying to get probably Canvas now, but looking that for the actual unit that you've done, and then the goals to master that. So it'll be all the stuff that you've been learning up until now. How long do I have to take the assessment, and is it timed? Yes, there is a time limit set to 180 minutes, but usually it will take you on average about 30-40 minutes should be fine. So you should have plenty of time to actually move forward. If you do need additional time, do reach out to Student Success. If you have trouble getting hold of Student Success, maybe speak to your SL or something. Can I use external resources? Now, the idea here is it's to test your knowledge, not test your Googling skills. So in general, I'd say no. The idea is it's supposed to test your fundamentals and the ideas and the concepts that you understand. So kind of looking for answers or looking for resources kind of negates the point of this test. It's not a test of how well you can perform if you have Google. It's purely a test on your understanding. So I'm going to say no, but if you've made notes yourself, then that augments your understanding, because you're not expected to remember absolutely everything in existence. If you can, great, that's amazing. But in general, you're not expected to. So things like using the training kit or your own notes, it still won't be considered cheating. And doing a little bit of searching will not. But just outright completely looking for answers to questions, that's something we need to avoid. Okay, that's kind of the general things that I needed to put across. Are there any track specific questions that we can cover right now or anything like that? Feel free to ask in your, if you're CSPT12 in the CSPT12 Build Week channel, and CSPT13, feel free to jump in and ask any questions there. I'm going to be flitting between the two, seeing if anything comes up. Okay, it seems like we've got no questions. That's a bit of a new one. I'm not used to that. Chris did say that he has questions, but what sort of questions, Chris? I'll move this onto screen so we've got a little bit more context. That's an interesting one. you may come across the problem of you're then kind of doing two projects. So you might want to liaise with your TLs on how that may affect things. One thing I'm all for things like that. That'd be amazing and great. The only things I can see is maybe if you're taking on too much work during the time. If you do have time and bandwidth to do that, then that sounds awesome. Let's have a look. Are there any specific libraries we can't use for Game of Life, specifically in Python? I don't know. If there's a Python Game of Life library, I'd say don't use that, because that'll pretty much do the whole thing for you, for instance. But no, I can't see a reason why there shouldn't be a library that you can't use. If it does the whole work for you and you don't have to do anything at all, then I'd say don't use it, because you're going to kind of negate the point. I'd maybe, sometimes I'd say steer a little bit away from Pygame, because it can be a bit finicky to get working. Other than that, that's not saying don't use it. It's saying just be mindful of, you may have blockers along the way. But I don't think there's any specific library that we can say, no, you're not allowed to use Game of Life in Python. Unless there's a, like I said, if you turn around and your library in Python, yeah, pretty much. I did have a little play with just using OpenGL as it was. That seemed to be okay. But again, like you say, all of them seem to be a little bit fun to play with. But yeah, I don't think there's anything, I don't personally have anything against you using libraries. At the end of the day, if we said you can't use libraries, we may as well say, well, you can't use data structures, you can't use a language, you've got to write your own or something, you know what I mean? But yeah, I'd say for the general algorithm, you're writing the algorithm. So a library to write the algorithm for you would be prohibited. But in general, I'd say if there's a nice UI that you want to use, or if there's some other library that doesn't really negate the point of what you're doing, then I can't see any reason why there'd be anything specific that you wouldn't be allowed to do. Moving back to the DS one though, personally, I'm all for it, Chris, but you may want to speak with your TLs and maybe with the team just to make sure that it's going to be within scope, so you can get to scope that, because that sounds like an awesome project to do. Looks like we've got something in here as well. Let's look at this. Does the grid have to be square? Can it use different shapes as grid cells? You mean visually? Do you mean actually like use a circle for each of the cells or something, or use a funny little shape, or did you mean the actual grid being, instead of it being a 25 by 25, you want it like a 25 by 23 by 7 by 9 or something? Yeah, that's fine. That's more visualization. As long as it's physically each cell still being a cell, it can be whatever shape you like. It's just ideally it still needs to be some form of a thing that can be linked together. As long as it can follow the rules of Game of Life, I've got no problem with it being round, you know what I mean, or hexagon or wherever. That's more of a visualization thing, and that's your decision how you want it to look as such. As long as you can make it work with the correct algorithms, then I can't see a problem with that. Where did I put the other channel? There we are. Just need to be checking both sides for this. Fancy. Awesome, Anthony. Great stuff, Chris. Yeah, like I say, personally, I think that would be a great thing, definitely. Right then, we're running a little bit on time, as in we're running a little bit low on time. So is there any other questions or anything that can be handled now? Because if not, we can leave it to your TLs, and I'll still be hanging around the help channels and stuff afterwards anyway. Oh, let's look. Pete, any getting started tips if we want to use Python? We've not done anything visual or web in Python. That's a fun one. I'd say probably look up, I don't know, either Flask or Flask's probably going to be your quickest route to a quick API. Or like say something like Pygame or visualizations of Pi. You can use tkinter, but that's a bit finicky as well. The problem what you're going to get is visualization wise is that there's a few things to choose from, but then all of them have their own drawbacks. I do actually enjoy Pygame as a visualization tool, and Flask, but there are loads of different little bits and pieces out there. So it's more going to be a case of that's going to be part of your research, if you like. That's part of the process itself. But awesome question. I might be able to have a little look in a bit, just to have a little nose around and see if there's anything interesting to drop. That being said, I think we'll wrap up here, and any more questions we'll get done sort of asynchronously, and we'll leave you guys to meet up and do your other things. Bearing in mind, we'll be around. Just because we're finishing up the kickoff doesn't mean we're not around to help. So remember to keep the questions coming. Let's stop sharing screen for now. Well, it's been awesome. Thank you so much, everyone, for your time and for your efforts. And I do wish you the best of luck with this build week. I'll be around for the entire time, and so will your TLs and SL. So bear in mind, use the resources what you've got. Use your core tracks, help channels, and utilize your peers when you're actually doing the planning and the thought process and the understanding. Okay. That being said, have an awesome one.